Good morning from the roof of the solar shed, and I'm looking once more at my two 100 watt monocrystalline panels because, well, a few weeks ago I showed that this panel is showing some signs of damage here. There's all sorts of cracks here. Now, there was some debate in that last video whether these are just snail trails and perfectly normal, or whether these are sort of micro cracks developing. And I guess I need to test that and find out whether this panel is producing less power than this one. So the easiest way to do that, I think, is to take these off the shed roof and put them in the garden, and we'll run some basic tests on them. Now, this damage could be a manufacturing issue, or it could have been caused in transit, I guess. Or finally, I guess, well, it could have been when I fitted them. I could have damaged these panels, or I guess something or someone has tried to clamber over them at some point in the past. I guess that's also a possibility. But without further ado, I'm going to get these two panels into the garden and we'll run some basic tests. So there are the two panels sat in the garden on a couple of chairs, going to be facing the sun. You can see I'm stood in front of the sun at the moment. This panel on the right is the one with all the defects on it. The one on the left, apart from a couple of points up here, is perfect. I will just clean that off as well, just to make sure that doesn't skew any results. Hopefully it shouldn't, but yeah, now I just need to look at the back of these panels, because, well, we've looked at the front quite a bit. So I've spun this defective panel around and we can have a look at the back. And it's very reflective, isn't it? But there doesn't seem to be any obvious issues around the back of that panel. No obvious water getting in or, well, any heat spots or anything like that. While we're here, we're going to check this label which is coming off, and we need to look at the open circuit voltage in particular, which says 22.3 volts, and the short circuit current is going to be useful as well, which is 5.9 amps. So 22.3 volts, 5.9 amps. Okay, let's do a few tests. Now, the connectors on the back of the panels are these MC4s, and these ones haven't been crimped. So it's given away really in the name, isn't it? The MC4 means that they are 4mm connectors, which means a standard 4mm banana plug will also fit very nicely, and that's how I'm going to connect to those MC4 connectors on the panels with my multimeter. So a male and a female banana plug should suffice. Right, well, I've been waiting for the sun to come out. I've wiped down both panels and I've connected them to these two multimeters, which are identical multimeters. I'm hopefully trying to be as fair as possible. The one on the left is connected to my control panel, and the one on the right to the panel which is questionable. And the sun's just gone behind the cloud, but they're both producing 19 point something volts, aren't they? They're about 0.2 of a volt apart, and I guess that could be multimeter differences. I guess I could swap them and check that. So I've swapped the two meters around. You can probably tell because this one's got a small crack in the screen, and again they're tracking pretty close. This good panel over here, the questionable panel just down here, the questionable one is possibly 0.2 of a volts lower as the sun goes behind the cloud again. Now the sun's gone behind a big dark cloud and hopefully it'll reappear soon, but it has given me the opportunity to flip the wires over, so I'm now measuring current, and as you can see again, this questionable panel is a little bit lower, but they're not producing much current at the moment because, well, that dark cloud is quite thick. But it is safe to short your panels because remember, it's not like a solar panel is a battery. It doesn't have any stored energy, so when it's open circuit it produces an awful lot of voltage, and when it's closed circuit it only produces current. So there's no power because of course you need voltage and current for power. So yeah, it's perfectly safe to short a single panel and measure its current in this way. So I just need the sun to come out again now, don't I? So that current is starting to rise now, just coming up to 2 amps, yes. And they're both tracking each other pretty closely, aren't they? 3.5 amps as that sun comes from behind those clouds. I wonder if we'll see a cloud edge effect. 4 amps and dropping away again. Yeah, but they're tracking very closely together, aren't they? There is a little bit of a difference, but not by much, and again that might be differences in cables or the shunt inside those multimeters, but they were tracking each other pretty well, weren't they? Here comes the sun again. Not seeing anything close to that short circuit current on the back of the panel, are we? But this isn't exactly a controlled factory test, is it? But after watching these for quite a while, they have been tracking pretty closely together. Now obviously I haven't been able to test this under any sort of load, and that might see some slightly different results, but I have been able to test the open circuit voltage and the closed circuit current and compare it with another panel of the same type which has less damage, and I'm not really seeing any considerable issues here. So I think for now at least I'll get them back up on the shed roof. Oh, the sun's coming out. Let's just watch that for a moment. Peaked at 3 amps. Oh, I seem to have lost a bit of the shed. There we are then, the panels are reconnected to the tracer A and are working. So there we are then, the panels are refitted to the shed roof and reconnected, and those small cracks don't seem to be having any major effect in this off-load test. Hopefully you've enjoyed this video. If you did, give me a thumbs up, subscribe down below, comment if you can, and I'll see you next time. Thanks for watching.